second lab. Hope you all are doing good. Hope you have completed lab 1 without any queries. If you have any queries, do mention in the comment section of previous video or this video. With that mention, what are we going to do in today's lab? We are going to make use of the same OpenAI SDK core framework. Core. Okay, no frameworks. We won't be using any frameworks, but like we mentioned previously, that OpenAI has a standard, and using that we can create multiple models, be it Claude, OpenAI, not it's be it Claude, Anthropic, Gemini, or Groq, Grok, or Groq, Gruq. We can create any number of. So we will be using Ollama today. And before we start, let's a quick glance on what we are going to do. We are going to use a different models, Ollama 4.1, 4o mini, and then we are going to play a bit around these parameters because we have done previously already. Then we are going to see, previously we have used just a JSON as a format, saying in which format I need the output, but this time we are going to create a custom class and we are going to say what is the output that we want, and then we are going to simulate as though we are giving a memory to the LLM, which is like we will talk about short-term memory, long-term memory, persistent memory. We'll talk about it, and finally, few more concepts which are relevant for creating our agentic AI workflow without any framework. Okay, so whatever things we are doing now, if we are writing 10 lines of code, once we go to frameworks, we are going to line 1 or 2 lines of code. Okay, so that is the reason we are starting with this. Okay, so with that mentioned, let's get started. So the step one before we do anything is we need to we will be downloading Ollama. Okay, so we will run in local. The good thing here is when you are developing something, you can play as much as possible because you don't have any limitation. It is running in your local model. So here is it. So just type ollama.com/download and you will be coming to this framework. Select whichever is your OS and click on download and start. That's it. So once you start, you will see something like this. This is their Ollama application, which you can see in your look, and you can see this Ollama provides so many models. Okay, now like we have seen during the discussion about the number of parameters in the LLMs, right? So if your system configuration is less, go for smaller models. If your system configuration is very good, go for higher models. But the recommended, the good one with least possible parameters is Llama 3.2, like the best one with least possible parameters, because after 3.2, if you go with the incremental version, then the amount of parameters in the LLM is heavy. So your system might not support, or it might take a lot of time. So we will be using Llama 3.2 in the Ollama. Okay, so these two things are good, and one more thing. So if you type anything high, you will get response from Ollama, but that model is running on your system. Now, by default, this Ollama is running on this port 11434. So just remember this, and we will use it in our coding. So with that mentioned, let's get started. So let's open our code base cursor. Okay. The step one is setup environment, and if I go to my environment file, I did not do any changes. We are going to use the same .env so far, which is our OpenAI keys, because the other that we are running is local, so we don't need to configure anything. Okay, let me zoom in a bit. Okay, so first thing is we are loading an environment variables and we are validating whether we got it or not. Now in step 2 is, if you remember, this is how we were creating OpenAI with API key, or else we can simply say OpenAI. Okay, anything is fine. But the second thing for Ollama, if you see, here I'm importing as Ollama client, but what I'm doing here is, here I'm simply saying the same argument instead of this thing I'm using this. So here instead of this API key, I'm using some random thing. Okay, this is just for the formality sake I'm passing. This is not an actual API key. We don't need to pass because it is my local, right? Now the second thing is, what is the base URL? So when I'm hitting it, where it should go and call. So since my Ollama is running on this, I'm giving this as base URL. Okay, I hope you understood. Now similarly, if you see OpenAI, you can pass Gemini's API key and its base URL. DeepSeek API key, its base URL. And then Groq API key, it's base URL. And Anthropic has a different standard. It's not using OpenAI, different standard. So you can use any model, but if you see common thing in all is all are using OpenAI, but you have to pass its API key and its base URL, and you are good. So in our case, we are going to use OpenAI, the default one, and the Ollama. So let's initialize this and make sure that this shows successful. Now step 3. So what we are going to do is, I've shown you previously that we can use either client response create or we can use Ollama chat completion create. Anything is fine. It will go to LLM and give us the response. But this when we should use when we have a single short use case. This when we have chat based kind of use case. Okay. So here we are just using the same methods. Okay. Just wanted to show that we can use any of these methods, but here I was passing GPT model. If you can see I'm in models. Here I am passing my Ollama model. Okay. And let's run for both of them. We are passing this message only. Now, if you see here, I was using client response create. That why I'm passing message as a prompt. But here I'm using chat completion. That's why I'm passing that message in this format. But can you use this format instead? Yes, you can. Now I have written this here in example that you can use Ollama response create. But in case of Ollama, this method is not implemented by the base URL have the should have the implementation, right? So it's not implemented for Ollama. That's why I can't use the response create. Instead, I have to use the chat completion only for Ollama. For chat GPT, both are the chat and the response create, both are implemented. That's why we can use any of them. Alright, so for both of them, we are passing our same user prompt and let's run it. Okay, so meanwhile it is running, I want to tell you something about what we are going to do in future. Here, when we are making an API call, so basically LLM call, it is making some request, getting some response, one single call. Tomorrow it might do 10 different calls. Day after tomorrow it could do 100 different calls. How do we know what LLM did behind the scenes? We don't know, right? So for that purpose, we should enable the tracing, which we are going to do with OpenAI and Langsmith in the coming labs, not as of now. So I see GPT-4o. Okay, what was my question? Explain the concept of reinforced learning in the simple terms. So first, the response I got from the GPT-4o, and then I got from Llama 3.2. You see, there is a difference on how each of them is giving response. But overall, we understood that Ollama or any type we take, the standard base implementation is OpenAI. Okay, it's like a standard. Okay, so this is one we created a client, and similarly, you can create a client for any number of any kind of models. Okay. Okay, so with that mentioned, now let's go for the next concept, which is streaming response. So what happens is when you're talking to ChatGPT, right, and you're asking it a big code, it won't, completely generate the response and then give it to you, right? If it does that, then what will happen? You will think whether it's working or not. You might refresh your browser, you might stop it, and you might ask again. So instead of that, we should go for streaming, right? And that is what we are doing is here. So we are not waiting for it to generate completely. As soon as LLM predicts the next word, it is giving it to the agent and agent is giving us. Okay. So here we are getting the response as a stream. Okay. So what I'm doing, client response stream. Okay. Instead of chat completions or simply response create, instead of response create, I'm using response stream. All right. So as soon as I get a stream, I can say event.type if this is the output text, because I can have different response types. So here, if the type is output text, then I'm printing it. Okay. So you can print it this way, or you can wait for the complete message to come and then print it. So to get the full response, you can capture the final message using final. Okay. This I kept just for response, just for reference, I mean. But in our case, we are simply printing out this one. And finally, once you're done, we are going to close it. So let's run this once again. So we can see because it's a small, we did not understood whether it's coming in streaming format or all in one, but it is actually coming in the streaming format. Okay. Next, we will talk about structured output and function calling. So if you remember in lab 1 what we said, hey LLM, you are giving me in some format, you give me in the JSON. So how we said that? By saying response format is type JSON. right? But in here, instead of saying that generic, we will now define a class, define a model, and then we will say, hey LLM, you give me the result in this specific class or DTO format. So what I'm doing here is I'm defining a schema called framework, which has two attributes, that is name of the framework, use case of the framework. These two attributes I am giving to a framework, and then to LLM I am going to ask some question, and in response I want it to give me the list of frameworks. So list of framework has a base model, which is a pydantic model, which says that you will be having an attribute called framework, which is simply list of framework which we defined earlier. So I think you are clear with this class. Now what we are going to do is we are going to use chat completion. Now if you see, okay, I'll talk about parts in a minute, but what we are doing here is just like anything else, model we are giving, then messages. What is a system prompt? You are a helpful assistant that returns a valid JSON. Okay, and now this JSON thing is mandatory when you are expecting JSON object, but as of now you are expecting some other format, so it's up to you whether you remove this return valid JSON or not. But the system prompt core intention is you are a helpful assistant. And what is our user prompt? User prompt simply says give me three AI frameworks and their main use cases. Okay, so and then this is the response format. So let's do one thing. Let me run it without the response format. Okay, and then I will print the response. Let's see what is the output. So let's do here print response. Okay, let's run it. So here I did not give any model and I simply say give me the output. So let's see what it is going to give. Okay, so it gave me past chat completion, and in the response if I see finish reason is stop messages contain. Okay, so it gave me this as a content. Okay, and why it gave me JSON? Because I said return a valid JSON. Okay, so that's why it is returning me in this format. Now if I remove this, then it will give me just like the text that it gave me above. Okay, so this is one format, this is second format, which because of valid JSON, and here I could say response format as this where is it, this one, type JSON object. But I don't want to do that. What I want to say, use this framework list pydantic model and give me that. Okay, so let's see the response now. What happened? Oh yeah, comma, and let's, okay, so now I'm going to see the response. If you see now, what is the response? Response is the framework list, which is the expected type. Now what is a framework list? It is a list of frameworks. So first item is this one. So choice one is framework list, my message. Okay, let me go to the content. Yeah, this is the content. So content has frameworks, and frameworks is a list of frameworks. So first framework is name, use case. Okay, then second framework is PyTorch and use case. Similarly, third one is Keras and its use case. But let's try. So you understood. We can either mention here or we can say give me JSON format. But if you need a specific class type, DTO type, you mention it explicitly using pydantic model, or in upcoming time we will use annotated ones. Now what I wanted to talk in parts. Yeah. So previously what we did is very careful. Okay. Chat completion. Let's go to chat completion. Let me, yeah. So chat completion create we said previously, okay, but when you are saying parsed, okay, so if you want to give response format pydantic model, you need to use parse. Now I am highlighting that as two reasons. First reasons, if you want to use response format as your own DTO, you go for parse. And second thing, in the response, right, you should use parsed message dot parsed. So previously you are accessing different attribute, but now you have to access the parse. All this you can get it from the documentation. What I'm trying to do is, if you see this is the content, right? Where is our content? This content I'm trying to extract. So response dot choices of 0 dot message dot parsed frameworks. Okay, so this I'm accessing, which is my structured output, and I'm trying to print it. So if I print it, I can see name and use case, name and use case. Okay, just like how I was getting in the this thing. So you try to play around with this framework DTO and see the output. So that's how we are structurizing the output. Now, moving on to the next concept, I hope so far it is clear. If you have any query, do mention in the comments. Okay. All right. So when we talk about memory, so when you're talking about ChatGPT, yes, and we are saying it has the context, it knows what we asked it previously. How is it doing? We have multiple methods, multiple ways. One way is when you're doing conversation, you persist everything in one place, be it database, be it file or anything. Okay. So when the next time the LLM or our agent is giving the input to the LLM once again, it gives our input plus the discussion that happened so far. Okay. Now the discussion that happened so far, it can bring either from a persistent memory, a file, or in memory anywhere. Okay. So we are trying to simulate that scenario here. So how we are simulating? First, I created a system prompt saying you are a memory capable AI assistant, and then a user prompt saying I studied transformer yesterday. So this is straightforward conversation. One user prompt, one system prompt. So if I first ask this to LLM, I'm going to get some response. Okay. So what I'm going to do is that response I am going to append again in my conversation. Okay. Previously in my conversation, it was only system and user prompt. Now I'm going to append the response that it gave me, and I'm going to ask question on top of that again. Okay, so what will happen now? The sample conversation becomes the system prompt, the user prompt, the response that it gave, and my next set of questions. So this again I will pass to LLM. Okay, so that's how it is going to answer me again. I hope you understood. So what we did is the response that LLM gave me, on top of that my question and the previous discussion all together again I am sending as an input for my next question. So this is how it will look like. So I'm running that also. Now, one thing is here I'm using what GPT-4o mini, but instead of that, you can go ahead with Ollama because it's running in your local, so you don't have to worry about your free quota being exhausted or something. The only thing is it will take a bit more time compared to GPT-4o mini. Okay, so this is the uh, answer that it gave for the first, and then if you see follow up. So follow up question is basically I am printing here, yeah, so I'm printing follow up the second response. So in the second response, when LLM gave me, the input that I actually gave was our previous conversation plus my current question again, the user prompt. So that's how it is working. I hope you understood how the memory, uh, it is taking all the previous context and responding again. Okay, all right. Now we are going to use a model comparison helper, which is our last concept. So we are going to showcase, we are going to use GPT-4o, GPT-4o mini, and Ollama, and then you can make use of the other clients as well, which I mentioned in the comment section on the earlier. So we are going to tabulate different metrics for it. For that, you can install this using UV or using PIP, up to you, but it should be inside your virtual environment. If you do it outside, it will be available for the whole environment, which defeats the purpose of the virtual environment. Okay, so I have done this, but let me do it again. So I've installed it. Then I'm writing a compare model here. Okay, so here I'm writing if condition for the GPT based models and else if conditions for the Ollama, because the client I have to use is different. Here I have to use the OpenAI client, here I have to use the Ollama. Overall, I'm passing the same prompt. You see, I'm passing the prompt and models. So I'm going to pass the same prompt, and then I'm going to tabulate everything, the latency, so basically the model, source, number of token or words it utilized, the latency and its response. All I'm going to tabulate for it. Okay. So this is just one way of comparison. Okay. So my tabulation is done. Now I'm passing, describe the concept of agentic AI, and the number of models that I'm passing is these three. So if I run it, I'll get, so we will give it some time and we will see how much time each took. Okay, so that is one thing. Now what else can we do here? Let me think. Yeah, so you can do one more thing while experimenting with this is you can give one question to this, same question to this, same question to this. All three will give you some answer or evaluation, right? With the human eye, you can try to evaluate which one is good, which one is bad, or you can give all these three responses to some other model and tell it to pick the best one. So you can try to do that evaluation. All this is different kinds of workflow or agentic patterns which we are going to learn, but you can try out that. Okay, so we got the output and we see the mini took 6.5 seconds, 4o took 5.26, llama took 19.3. And you can see number of tokens and words, and in below you can see the responses from each. Okay, now here token or words are different. And let's say you can also try to see the comparator by tuning the parameters. So for example, here when I am calling, okay, prompts and models, maybe you can take a default value for the temperature, maximum tokens and such. Okay, just for your information, here it is 250. Here we did not keep anything, so you can tune and play around with it. Okay, so that was just one way of comparing the models. You can consider different metrics or use different agentic patterns to evaluate which one is good, which one is bad. We will talk about that in our coming lab. So what all we learn is we understood how we can compare multiple LLMs. We tuned a bit using temperature and maximum output tokens in previous labs and in this a bit slightly. And we use Pydantic to, structurize our output, and we can make use of that for our further flows in the workflow. And we touch based across few concepts like uh, providing context memory, okay, using multiple models, and streaming of the outputs, and structurizing outputs, which are all we will be using in the agentic AI systems, the workflows that we are going to create. Okay, so I think that's all for today, and we will be meeting in the next. Let me see 1 second. Yeah, we will try to see few more concept on the core framework. So the way we are trying to proceed ahead with the next topics is once we clear with all the topics that is relevant to us for building the agentic pattern, we will move on to the framework. Okay, let's say OpenAI based framework. Once we are done with that, then we'll go to more abstracted layers of framework. So like that, we will increase the uh, abstraction levels and the kind of frameworks that we are using, and finally we'll end up with the MCP server, so which is the most interesting topic, and we will talk about that as well. So that's all for today. If you have any comments, any suggestions, or any things for the improvement, do mention in the comment section. And yeah, click on the notification bell icon and do subscribe so that you get all further notification of all the labs that we are planning to do, and you can follow along. So thank you and all the best.